Okay, let's make sure recording. Okay, good. Let's start repro 3 with female. So we'll start right here. We're talking about the major female organs, the gonads, ovaries, fallopian tubes, the uterus with the myometrium, which is the muscle, the smooth muscle layer, and the endometrium, which is the lining of the uterus. And the endometrium has two parts, the stratum basalis and the stratum functionalis. Stratum basalis is always there. The stratum functionalis is the part, the very outer part of the, or inner part of the endometrium. No, I mean the outer part toward the lumen of the endometrium. That is where a possible blastocyst will implant. And it is what is built up during what's called the uterine cycle, starting from the end of the menstrual cycle to the start of the next menstrual cycle. It's the stratum functionalis that builds up. It's the stratum functionalis that breaks down and forms the menstrual flow after the loss of progesterone. And there's, right from the book, pictures of the uterus and the ovaries and the fimbri that surround the ovaries and the ligaments that hold things in place. These are things you need to know for the reproductive anatomy lab course. You're talking about the vagina, obviously where the penis is put during sexual intercourse, coitus. In prepubescent adolescent females is covered by the hymen, and that's usually penetrated, broken during sexual intercourse and more. It has ridges, rugae inside the vagina. It has a transudation. This is this fluid that comes right through the vaginal wall during sexual excitement. And this is the usual lubrication for sexual intercourse. Mostly that is the response to the female. I mean, a little bit, as we say with the bulbourethral glands, that helps with a little bit of lubrication, but mostly it's a transudate through the wall of the vagina. Metaplasia. This is something really unusual. This is I think we mentioned this during last semester during the tissue chapter, where this is the change in epithelium from over the course of someone's life. And that is in a young girl's vagina, its epithelium is a cuboidal epithelium, and as she reaches puberty, it gets older, it changes to a stratified squamous epithelium. Production of lactic acid, the vagina is usually an acidic environment. And that's actually not good for sperm. Sperm don't like acid. That's one reason why you need more sperm, why you need hundreds of millions of sperm, because some of them are killed by the acid conditions. Semen is sort of like a little basic, and it helps a little bit. Dendritic cells, it's lined by dendritic cells. It's a mucous membrane. The mucous membranes are lined by these dendritic cells. Remember, those are white blood cells, they're immune cells that are the first barrier against infection from openings in the body open to the outside. Of course, the vagina is one of those openings. And they actually kill some sperm cells. That's another reason why you need more sperm cells. Because sperm cells, after all, are foreign cells that have been introduced into a female body. So dendritic cells are actually going to kill some sperm. Okay, the external genitalia. The vulva is the area within the labia minora. And there's two openings in there, the external urethral opening and the vagina. It's also called a vestibule. Okay. Now the clitoris is a little dorsal to that, and it has a prepuce as well, a little hood over the clitoris. And the clitoris is the homologue to the glans penis. And there are vestibular bulbs that are attached to the clitoris and actually line the very outside of the vagina. These are actually erectile tissues. So females get erect during sexual excitement as well. The clitoris does these vestibular bulbs, and they're said to be homologues to the either corpus spongiosum or corpus cavernosum of the in the male penis. There's two of them, so I would think they'd be more homologous to corpus cavernosum. And then there are glands, like retrovestibular glands that are either side of the vagina, and they are homologous to the bulbourethral glands, and they make a little bit of lubricant for sexual intercourse also. Remember, so all of these glands, a lot of this tissue is homologous. Remember, it's the same fetal tissue that has taken different directions depending upon the presence or absence of testosterone at the 6th week of fetal development. Okay, breast, mammillary glands. We are mammals. We feed our infants with mother's milk. They're not really sexual organs, or they certainly become some, but more organs that are useful after the results of sexual intercourse. Okay. But we're treating them as sexual organs. Okay. There's a cross-section of the sagittal section of the female reproductive system. We won't really be talking too much about the urethra. The orifice of the urethra is in the vestibule, but I mean, female urethra has nothing to do with reproduction. It only carries urine. Male urethra, however, does double duty, so it is something that we talk about during the reproductive system. Puberty and menopause. So we have a hypothalamus, pituitary ovary axis, right? GRNH from the hypothalamus, which is first produced at puberty, stimulates the production of FSH and LH from the anterior pituitary. FSH and LH stimulate the production of estrogens, female sexual hormones. The most common is called estradiol, from the ovary. Right? And then we're going to learn that estrogen feeds back upon the hypothalamus and pituitary to turn off FSH, LH, and GnRH. All right, so the FSH and LH from the adenohypophysis, which is the anterior pituitary, follicle stimulating hormone, and luteinizing hormone. And these start, FSH starts the follicular development in the ovary, starting with primordial follicles to primary follicles to secondary to a graphic follicle. And estrogen is secreted by follicles in the ovaries, and that helps follicular development also. Okay, puberty stages. Females have 3 stages of puberty. First is thelarch or breast development. Next is pubarch, pubic and axillary hair development. I guess you could put that in males also. Males get pubic hair, axillary hair at puberty, but they don't have different stages for male puberty. So thelarch, breast development, pubarch, pubic and axillary hair, and finally medarch, first menstrual period. Actions of leptin. It's the age at which puberty begins in females has been dropping for centuries. It used to be actually 18, 19. Now it's down to 12, or even sometimes even earlier than that. And it might be due to actions of leptin. Leptin is, remember, a hormone from adipose tissue. And it tells the body how much fat you have. And it also has a role in seemingly timing the role of puberty. Now, maybe because of better nutrition we've gotten over these centuries, women have been putting down more subcutaneous fat and becoming more healthier. And therefore, and it's really tied to being able to maintain a pregnancy. You have to have enough fat to maintain a pregnancy. And if you don't, this hypothalamus, hypothesis ovary axis will come to a grinding halt. There won't be an GnRH made because you don't have enough fat to maintain a pregnancy. And this happens sometimes to female marathon runners. They get so thin, so little fat, they become amenorrheic, which means that their menstrual cycle stop. Okay. Hormones. Progesterone acts on uterus. So we're going to talk about progesterone in the second half of what's called the ovarian cycle. Something called the corpus luteum makes progesterone, and it really stimulates what's called the proliferative phase of the uterus. It really builds up, causes angiogenesis, builds up these arteries in the stratum functionalis. Inhibin is going to be secreted by the corpus luteum also, and it's going to actually inhibit FSH secretion. Estrogen does also, but inhibin does as well. In the first part of the cycle, estrogen will inhibit GnRH, FSH, and LH. But then right near the middle of the cycle, estrogen actually becomes stimulatory to FSH and particularly LH. And we're going to see that that's going to cause a spike in LH at around day 14, and that's going to signal it's going to initiate ovulation. Okay, climacteric and menopause. Symptoms, hot flashes, possible bit of bone loss, and the onset of menopause, usually in the late 40s, early 50s. Some women take hormone replacement therapy to deal with these symptoms. The reason is not known. Why do women have an end to their reproductive life and their ovarian cycle stop and they stop making stop follicle development? Nobody knows, but it happens in human females. Some speculation that if you really, get elderly, you won't really live long enough to take care of really helpless infants. Human beings have what's called altricial infants. They're absolutely helpless, and they need years of help from both parents in order to survive, particularly back when we were hunters and gatherers. But remember, 50, 100,000 years ago, what was our life expectancy? 40, 45, if we're good. So actually, most women would never even experience menopause because they died before experience it now because our lifespan is that much longer. Anyway, whatever the reason, it exists. Okay. So oogenesis is meiosis, female meiosis. Oogonia are the cells that start the follicular development and start the production of a gamete, of a viable gamete. And these polar bodies are bodies that are sets of chromosomes that are thrown away because at the end of female meiosis, there's one gamete made, just one. Males have 4 from each spermatogonia makes 4 functional gametes, oogonia only made 1. And they always make a first polar body. They don't always make a second polar body. We're going to learn that when we get to that. These oogonia do not finish meiosis unless they are fertilized. Okay. So folliculogenesis happening in the ovary. So we're going to look at cycles in various organs. Cycles in the brain, in the hypothalamus and anterior pituitary. Cycles in the ovaries, in folliculogenesis, and then cycles in the uterus, building up the lining of the stratum functionalis, of the endometrium. Okay, so we're going to look at primordial follicles, primary follicles, and then secondary follicles with these granulosa cells, and with an antrum, with a fluid-filled cavity. And there's going to be a primary oocyte that's surrounded by a zona pellucida. And here is oogenesis on the left, follicular development on the right. So oogenesis is the development of oocytes, and this is really essentially meiosis. And remember, all the oogonia are first arrested in prophase 1. They're selected at the beginning of the cycle, actually during the menstrual flow of one cycle. Primordial follicles are already being selected and to continue meiosis, and they go through meiosis 1, and they kick out the first polar body that has 23 replicated chromosomes. And then they go on, and then the oocyte goes until metaphase 2 and is ovulated in metaphase 2, and then never finishes meiosis and makes a second polar body unless it's fertilized. Follicular development on the right, you can see primary follicles, secondary follicles. As I mentioned in lab, it was an error in lab. They label some follicles that don't have an antrum fluid-filled space as a secondary follicle. They are secondary follicles when they have an antrum. Then finally, we have the mature follicle or graphene follicle. We have ovulation, and then the cells that are left over in the mature follicle after the primary oocyte has left becomes the corpus luteum. And if there is no fertilization, corpus luteum would degenerate in about 11, 12 days, becomes the corpus albicans. And then in the next chapter, we'll look at how the corpus luteum is maintained if there is fertilization and an implantation event. Okay, so you could call a primary, a mature follicle also a tertiary follicle. Has an antrum, fluid-filled space. It has a cumulus oophores. It's like a little peninsula where the primary oocyte is surrounded by these corona radiata cells, and it's like a peninsula in a lake. This is called the cumulus oophores. I'm not going to go into that. So the mature graphene follicle is a tertiary. Okay. Let's get into the sexual cycle. 28 days on average. So we're going to look at the changes in the hypothalamus, in the pituitary, in the ovaries, and in the uterus. And here is a cross-section of, again, of an ovary with pictures of the different follicles and follicular stages, and the corpus luteum and the corpus albicans. Okay, so ovarian cycle. Follicular phase, day 1 to 14. There's a follicle is being developed. So it's pre-ovulatory. So it's before ovulation. It's the most variable stage. It usually lasts 14 days. Can be a little, last a little few days, a little more days. But usually lasts 14 days. Stimulation by FSH. FSH starts the ball rolling with selection of primordial follicles to start making primary follicles and continue meiosis. FSH decreases over the course of this follicular phase. And, but we'll see that estrogen actually increases a little bit. And so what it's thought is that these primordial follicles somehow, primary follicles, compete for FSH. And the ones that make the most FSH receptors wins this little competition and becomes the egg of the month, and the rest degenerate. So these follicles upregulate receptors to gather more and more FSH, because FSH falls over the course of the follicular phase. Then at ovulation, it gets turned around. Before estrogen was inhibiting FSH, now estrogen stimulates FSH. So a little FSH surge, but more importantly, there's an LH surge. We're at day 14. And this causes ovulation. It stimulates ovulation, the LH curve surge. Then after ovulation, we have the luteal phase, the formation of the corpus luteum, secretion of progesterone inhibited from the corpus luteum, and then finally involution of the corpus luteum if there is no implantation event, involution of the corpus luteum, formation of the corpus albicans. So the menstrual cycle, or really the uterine cycle. Now day 5 to 14 is called the proliferative phase, and there's a lot of mitosis going on, stimulated by estrogen. There's a big estrogen surge during the proliferative phase. So it's mitosis building up the lining of the stratum functionalis. Then secretory, after ovulation, is called the secretory phase, day 14 to day 26. And this is really a period of angiogenesis, making blood vessels, lots and lots of blood vessels. These are called spiral arteries, and they're unique to the lining of the uterus. And it gets really, really engorged with blood. I think that's why it's called secretory. And this is under the influence of progesterone. Progesterone does this. Then pre and menstrual phases, last 2 days, if, like I said, no implantation event, corpus luteum involutes, progesterone drops down to practically nothing. This is called an ischemic phase because these blood vessels just shrivel up. Ischemia is a lack of blood. So these vessels degenerate and break apart, and the blood flows, the menstrual blood starts to flow out, and then it starts the menstrual flow. So here it is right here, the ovarian cycle, the gonadotrophin levels, ovarian hormone levels, and uterine cycle. So you can see the menstrual phase at the very beginning, the menstrual flow from the last month, right? And you can see that the FSH rises during the menstrual flow and actually starts stimulating some primordial follicles when the menses are flowing, through the menstrual flow, because you need actually a little bit more than 14 days to make a secondary oocyte and get it to a point where it can be ovulated. So the primordial follicles are stimulated during menstrual flow, and then it can come into primary follicles. So the FSH is high at the beginning of the cycle, and the estrogen is low. And as FSH is made, estrogen rises. This stimulates the proliferative phase of the uterine cycle. Start making secondary follicles in the ovary, And then notice we have a spike of estrogen just before ovulation, and just near the end of the proliferative phase. Now estrogen becomes stimulatory to FSH. You see how FSH really drops off quite a bit just before ovulation, but then it spikes. Because it's a complex relationship between estrogen and FSH. In the early part, estrogen inhibits FSH. And right near ovulation, day 12, 13, it becomes stimulatory. And it becomes stimulatory to LH. And this huge LH surge, as you can see that, leads to ovulation. And then the corpus luteum forms, starts making progesterone. You can see at the purple is the progesterone, how that really rises. And that does a secretory phase. You can see all those blood vessels being made in the stratum functionalis of the endometrium and getting ready for a possible implantation. But then if there isn't one, regression of the corpus luteum into the corpus albicans, notice how progesterone drops right down to very low levels, and these spiral arteries and its stratum functionalis start to fall apart, and the menstrual flow starts all over again, and we get into the menstrual phase of the next cycle. And FSH, you can see it, the orange, FSH beginning to rise even before the menstrual flow starts, to try to select some more primordial. So you're actually starting some primordial follicles going before this cycle ends, this month cycle ends. And before the menstrual flow even starts, you've already selected primordial follicles for the next cycle. Okay. And then 5 days or so of menstrual flow, and then we do it all over again every month. Okay, there is the axis, the hypothalamus, pituitary, ovarian axis. Hypothalamus secretes GnRH, which stimulates anterior pituitary to secrete FSH and LH. They stimulate follicular development. Maturing ovarian follicles secrete estrogen and inhibin. And inhibin inhibits the anterior pituitary, inhibits the hypothalamus, and it stimulates follicular development. But it also will inhibit anterior pituitary and hypothalamus also. But notice right near ovulation, you see estrogen is now in green, has green arrows, and it is stimulating the anterior pituitary and hypothalamus. And then afterwards, progesterone, estrogen inhibin will inhibit the hypothalamus and the anterior pituitary. So it's a complex relationship between these hormones in this axis. Okay, female sexual response, it's really pretty much the same as male sexual response. We have excitement and plateau, vasoconstriction, raised heart rate, blood pressure, respiration, and erection. And as I mentioned, females have erections also. The clitoris, the vestibular bowels become erect. There's a vaginal exudate, which provides lubrication for sexual intercourse. There's something called the after intromission. Intromission is the inserting of the penis into the vagina, and leads to orgasm, and what's called the orgasmic platform. The walls of the vagina and these vesicles actually grip the penis a little tighter. It's called the orgasmic platform. Right at orgasm, this was called a tenting effect. And this is that the usual uterus is usually prolapsed over the top of the bladder. At climax, it raises up, so it's almost vertical, and this is called a tenting effect. The stimulation of the clitoris, the thrusting of the penis pulls the prepuce over the clitoris and stimulates the clitoris. Breasts are a little bit congested also. So orgasm, cervix plunges into vagina and probably will assist sperm in getting into the isthmus of the cervix. Peristaltic waves in uterus. The peristalsis will start the uterus to help push sperm up into the uterus and into the fallopian tubes. There's tachycardia and hyperventilation. Heart rate and breathing rate goes up, of course. Then after orgasm, after climax, there's a resolution phase where the uterus goes back over the bladder and heart rate and breathing might go down, but there is no refractory period. So here's one big difference between male and female sexual response. No refractory period in females. They can get excited again, go right up and have orgasm again. They can have multiple orgasms. Well, males only get one, and then they got to go through a refractory period before they can do it again. Okay, I'm going to get, that's the end of chapter 28. I'm going to stop it there, make that repro3, and then I'm going to be talking about a little bit about development, fertilization and development in chapter 29. So we're going to do a little bit of chapter 29. So I'm going to call it right there and see you for, so that's the end of repro. Wait a minute. End of repro 3, and then we'll see you in repro 4.